Okay, our second lesson in Unit 5 for 9:30. So last lesson we talked about simplifying radicals when they were not perfect squares and what to do with all that. So today we're going to start our operation. So we're going to talk about how do you add and subtract radical expressions. And part of that is learning what things called like radicals are, and in order to add or subtract those. So here we go. For our warm-up, let's throw back to just adding and subtracting when we have variables, because radicals work very similar to how a variable works. So go ahead and see if you can just simplify these, add or subtract, combine your like terms. Go ahead and do these, pause your video, and then check the answers. All right, so the first one, I have x plus 3x, right? Now, those are both like terms because they both have an x. And so if I'm going to add my like terms, I'm just going to add the coefficients, right? This is really the invisible one. So this is 1 plus 3 gives me 4x. Notice that my variable didn't change. I only added the coefficients in front, right? Okay, so now the next one, I have negative 3w plus 5y minus 15w. So if you look for your like terms, that's only the first one and the last one, right? So those are the only ones that I can combine. So I have negative 3w and negative 15w, which gives me negative 18w. The plus 5y is not a like term, so it just stays how it is. So my final answer there would be negative 18w plus 5y. Again, notice the w didn't change. I only combined my coefficients there. And then if it wasn't a like term, I couldn't combine anything. It stayed how it was. All right, third one then, I have negative 5x squared plus 8x squared. And those are also like terms, right? They're both an x squared, so I can combine them. So what I'm going to do is just combine my coefficients. So negative 5 plus 8 gives me positive 3x squared. Remember, again, the variable doesn't change. It's only the coefficients that you're combining when we combine our like terms. All right, so hopefully that was a good review of what it's like when you're combining like terms, because the thing is, radicals work exactly the same way. The only thing is you need to have like radicals in order to add or subtract them. So what do we mean by like radicals? Like radicals have the same number on the inside of the radical. Okay, so the same thing on the inside of the radical. That's what makes like radicals. So for example, if we wanted to make some examples of like radicals, we could say 2 radical 3 and 5 radical 3. Those would be like radicals. The 3 is the same on the inside, right? We could say negative 6 radical 5 and just radical 5. They're both the same on the inside. You could get pretty complicated, right? And you could say negative 2 radical 3xy and 4 radical 3xy. As long as whatever on the inside of the radical is the same, those are like radicals, okay? So things that are not like radicals would be things like 2 radical 3 and 2 radical 5, right? The number on the outside is the same, but not the number on the inside, so those are not like radicals. Another example of something that would not be a like radical might be like negative 3 radical x and 4 radical y. Those are not like radicals. Yes, they both have a variable, but they're not the same variable, so they are not like radicals. Okay, so as long as what's on the inside of the radical is exactly the same, the two are like radicals. So now let's talk about how do I combine these things that are like radicals. So first one here is radical 2 plus 3 radical 2. Are they like radicals? I have radical 2 and I have radical 2. The number on the inside is the same. So yes, these are like radicals. So just like when we combine like terms, when you combine like radicals, what you're doing is you are just combining the coefficients. So the number in front of this is 1 radical 2, right? There is 1 radical 2 there. So I am going to combine the 1 and the 3. I have 1 radical 2 plus 3 radical 2's, which gives me 4 radical 2. So just like with like terms, you are combining your coefficients, those numbers in front of the radical, but the radical doesn't change. So they have to be like radicals to combine them because that radical needs to stay the same after you've combined them. If they were two different radicals, which one do we keep? I don't know. And that's because the radical doesn't change. So combine coefficients and the radical stays the same. Combine coefficients. Whoops. And then the radical stays the same. If you notice, if we go back to our warm-up, I have 1 radical 2 plus 3 radical 2, and I got 4 radical 2 as my answer. If you look back at your warm-up, I had 1x plus 3x gave me 4x. It works exactly the same as like terms, so just keep that in mind. Okay, so now let's look at number 2. Now, I know you guys are freaking out. Number 2 looks crazy, but don't worry. Calm down. It's fine. We can do this. First thing is, are they like radicals? Negative 3x to the third, radical 5y to the third. Negative 15x to the third, radical 5y to the third. Yes, those are like radicals. It's fine. We can do this. All right, so my radical doesn't change, so I have 5y to the third is staying in my radical. What I do is I combine my coefficients. Negative 3x to the third minus 15x to the third. Now, if I just had negative 3x to the third minus 15x to the third, those are like radicals, right? I would just combine my numbers in front. I'd get negative 18, like terms. Negative 18x to the third, right? Go back and look at your third warm-up here. Negative 5x squared plus 8x squared is just 3x squared, right? I didn't change this because it's an x squared, doesn't change the process. The variable stays the same, the radical stays the same. The only thing that you're combining there are your coefficients. So I have negative 18x to the third, radical 5y to the third. No big deal. You guys can do it. Even when they look insane, like number 2, it's still just combine those coefficients. Everything else stays the same. Now, you might think that we're done here, but you'd be wrong. Because even when we are combining things with adding and subtracting, we still always need to make sure that our answer is simplified. Look at that radical again. Can I simplify that radical? And the answer is yes. Look at that y to the third. I can simplify that y to the third. So I need to break this down. This becomes the square root of y. And the square root of y squared. There is a hidden perfect square in there. So this guy needs to come to the outside, right? So I have my negative 18 x to the third that's already out there. And now I'm going to add to it. Square root of y squared is just y. So that needs to come out to the outside as well. And the inside I have a 5. That's staying put. And the y is staying put. So I have negative 18x to the third y, radical 5y. That's my final answer. So make sure that you're always simplifying. Even after you are adding or subtracting, we still need to simplify today. So we're kind of doing an extra step and then finishing with what we did yesterday. All right, those were crazy. That second one was crazy. We won't get that complicated on you, but I wanted to show you that, hey, you can do it even if you have something crazy, like number 2. All right, let's take a look at number 3. See if you can figure that one out. Pause your video. All right, now there are, if you notice on this one, those are like radicals, right? So I have a radical 12 and both of them, so I can definitely combine these. My radical is going to stay the same. And then I'm going to combine my coefficients here. So I have 7 and I have negative 4. So 7 minus 4 gives me 3. So 7 radical 12 minus 4 radical 12 gives me 3 radical 12. Just like the last one, though, we're not finished yet. We need to simplify. So I can break down radical 12 into square root of 4 times the square root of 3. 4 is a perfect square. So I'm going to have the 3 is coming down from before. Now the square root of 4 is 2. And that square root of 3 on the inside cannot come out, so it stays in there. So I'll have 3 times 2 on the outside, radical 3, which really gives me 6 radical 3 as my final answer. So don't forget, after you've combined your like radicals, always see if you can reduce. All right, now let's look at number 4 here. Negative 9 radical 3 plus radical 24. Well, those are not like radicals, right? So I can't combine them. But I can break down the square root of 24. Maybe if I break down the square root of 24, I'll get a like radical. Let's find out. Let's see, for looking for perfect squares, I could break that into the square root of 4 times the square root of 6. All right, so the square root of 4 is a perfect square. So negative 9 radical 3 is coming down the same, plus now I have 2 coming to the outside. Square root of 4 is 2. Radical 6 is staying the same. Oh, shoot. Those are still not like radicals. I've got a radical 3 and a radical 6, so I cannot combine them. So this stays as my final answer. So just like in that second warm-up we did, way back here, right, this middle one, here I had ones that weren't like terms, so I ended up with 2 terms in my answer. That can happen with radicals too. If you don't have like terms, then you can't combine them. So that's how it's going to stay. But we do have to simplify. Even if we don't end up being able to combine them, we still need to simplify before we say we have our answer. All right, let's try these last couple here. See if you got the hang of it. So go ahead and work on number 5. All right, right now, no like radicals, so I need to try and reduce this radical 18 first. Square root of 18, that's the square root of 9 times the square root of 2. 9 is a perfect square, so square root of 9 becomes 3. The radical 2 stays put, 3 radical 2. Bringing down the rest of it, plus 6 radical 3 minus 4 radical 2. Notice I am copying everything down so I don't lose any little negatives or anything like that. So now let's take a look. 3 radical 2 plus 6 radical 3 minus 4 radical 2. I see. I do have a pair of like radicals, right? So I'm going to combine my coefficients. 3 radical 2 minus 4 radical 2. That would end up with negative 1 radical 2. Or you could just write it as negative radical 2. That would work as well. And then I have to have plus 6 radical 3 because that's not a like term or a like radical. So you could write it either way, negative 1 radical 2 plus 6 radical 3, or just negative radical 2 plus 6 radical 3. A common question I get is, can you switch the order? Absolutely, that's adding, that's the commutative property, so you could do 6 radical 3 minus radical 2. That would work as well. Or minus 1 radical 2, that would work too. So the order doesn't matter, just watch that negative. The negative has to go with the radical 2, right? But since it's adding, you can definitely switch the order there. All right, last one here. See if you can take a shot at it. Okay, so let's see. Square root of 12, definitely need to break that one down. That becomes the square root of 4 times the square root of 3. The square root of 48 you can break down. There is a long way, but the short way would be the square root of 16 times the square root of 3. All right, so bringing down the 5 plus the 2 needs to come down to the outside, but now joining it, the square root of 4 is another 2. So I have 2 times 2, and the radical 3 is staying on the inside. So there's for that middle, that second term, bringing down the minus 3, bringing down the minus sign, right? But now I have on here the square root of 16 becomes 4, and the radical 3 stays put. Let's see, this guy needs to do some combining. So I have 5 plus 4 radical 3 minus 3 minus 4 radical 3. Let's look for our like terms. I see I have a radical 3 and a radical 3. So again, we're going to combine our coefficients. Whoa, hang on. Positive 4 radical 3 minus 4 radical 3, those are completely gone. They cancel each other out completely. So you could write 0, but we don't always have to write 0, but definitely don't write a radical 3, because if you just write radical 3, that really means 1 radical 3, and 4 minus 4 is not 1, okay? I suppose technically you could write 0 radical 3, but I would want you to keep going and just get 0, and then 0 you don't really have to write. So I would say when they cancel out completely, they are gone. We don't even want to write a radical 3. All right, but I notice I still have a 5 and a negative 3. Now, even though those aren't radicals, they're still like terms, right? So 5 minus 3 gives me 2. And there are no more radical 3's left, so my final answer is just 2. All right, hopefully you're feeling confident in adding and subtracting your radicals. Remember, you can only combine them if they're like radicals. That means they have the same number on the inside. Add and subtract the coefficients, but the inside the radical stays the same. And then don't forget that you might need to simplify before or after you combine them.